Good day, everyone. In this video, we will solve problems related to gas and power cycle from the Module 6 of Thermodynamics and Heat Transfer. This is our problem number 1. Determine the thermal efficiency of an Otto cycle with R of 8. Pressure is equals to 90 kilopascal. Temperature 1 is equals to 18 degrees Celsius and a maximum temperature of 1300 degrees Celsius. So the given in this problem are, we have R is equals to 8. The pressure we have 90 kilopascal and the temperature 1 is equals to 80 degrees Celsius. So we need to convert degrees Celsius to Kelvin. So we need to add the temperature of 273. So we have 291 Kelvin. So the same way for our temperature 3, we have 1300 degrees Celsius plus the 273 is equals to 1573 Kelvin. So since the question that is being asked is to determine the thermal efficiency, so the formula for our thermal efficiency is equals to W net over the QH. So in able to get this formula, so we need to find first the W net. So the formula for this is equals to Q in minus the Q out, and then the formula for our Q out is equals to CV times the T4, the temperature 4 minus the temperature 1. The formula for our T4 is equals to T3 times the V3 over V4 raised to K minus 1. Our Q in is equals to CV times the T3 minus T2. And the formula for our T2 is R raised to K minus 1 times the T1. So in able to get our thermal efficiency, so we need to find the answers of this following formula. So let's start with our T2. So going up to our thermal efficiency. So first thing we need to solve is the T2. We have the formula of T2. R raised to K minus 1 times T1. So our R is 8. Our K is constant, which is 1.4 minus 1 times our temperature 1. We have the 291 Kelvin. So let's solve. We have 8 raised to 1.4 minus 1 times the temperature 1, which is the 291 Kelvin. So we have our T2 is equals to 668.54 Kelvin. So next, we need to solve the Q in. Our CV is equals to 0.718. So Q in is equals to 0.718 times our temperature 3 in the given, we have 1573 Kelvin minus the temperature 2, which is the 668.54 Kelvin. So let's solve. Times 1573 Kelvin minus 668.54. So our answer is yes, we have 649.40 kilojoule per kilogram. So next, we need to solve the T4. So our T4 is equals to T3 times V3 over V4 raised to K minus 1. So our V3 is 1 and our V4 is 8. So let's solve this. We have 1573 Kelvin times 1 times raised to 1.4 minus 1. So we have 684.67 Kelvin. So next, we need to solve our Q out. So the formula for our Q out is CV times the T4 minus T1. So let's solve this. 0.718 times our T4, which is 684.67 minus 291. So we have 282.63 kilojoule per kilogram. So let's proceed to our W net. So W net is equals to Q in minus Q out. So let's just input the following. So W net is equal to 649.40 minus 282.63. Have our W net is equals to 366.74 kilojoule per kilogram. So let's now solve our thermal efficiency. So the formula for our thermal efficiency is equals to the W net over the QH. So let's solve 366.74 over 649.40. So our thermal efficiency is now equals to 0.5647, or it is 56.70 no 56.47%. So this is now our thermal efficiency. Thank you guys for watching.